Welcome to Life is But a Stream, the podcast for tech leaders who need real-time insights. I'm Joseph Moraes, technical champion and data streaming evangelist here at Confluent. My goal? Helping leaders like you harness data streaming to drive instant analytics, enhance customer experiences, and lead innovation. Today, I'm talking to Tim Berglund, Vice President of Developer Relations at Confluent. Tim works to make data streaming and its evolving toolset more accessible to developers everywhere. In fact, you might know Tim from...
And because of that, while I'm generating all that data and retaining it forever, I can go see to my chores. You know, I'm not one of those ivory tower guys who's just inflexible. I'm not afraid to get my hands dirty. I'm not afraid to help take care of the infrastructure myself. Like, if you're not freezing in that data center, have you really earned it?
Today, we're diving into the fundamentals of data streaming, what it is, how it works, and why it's becoming such a powerful tool for modern data systems. And just a reminder, this episode 1, episode 2, and episode 3 are part of our foundational episodes where we analyze and discuss what data streaming, stream processing, data integration, and data governance are. In future episodes past 1 through 3, we're going to be talking to our customers and all the great things they've built with the data streaming platform. But in this episode, we'll explore key concepts like real-time event processing, the difference between streaming and batch processing, and take a closer look at some of the use cases that are shaping the way businesses handle data today. But first, a quick word from our sponsor.
Your data shouldn't be a problem to manage. It should be your superpower. The Confluent data streaming platform transforms organizations with trustworthy, real-time data that seamlessly spans your entire environment and powers innovation across every use case. Create smarter, deploy faster, and maximize efficiency with a true data streaming platform from the pioneers in data streaming.
Welcome back. Joining me now is Tim Berglund, Vice President of Developer Relations at Confluent. How are you today, Tim?
Hey, Joseph, doing well. Thanks for having me on the show.
Awesome. So even though this is the first show, I'm going to immediately go off of our topic questions, all right? I just want to tell you a little bit about...
Nobody even knows what that flow is yet, but you're already...
you're right. I like to get in immediately and break things, right?
Okay,
That's just how I do. I'm an engineer at heart. So
Love it.
I started here 4.5 years ago. And we had a training system. We've gone through so many, I don't even know what the name of it is anymore. But there was this intro to Apache Kafka. And it was you. And I was like a brand new partner SE. And I saw you talk about data streaming in such a positive and interesting way. I didn't really know that technologists could talk about tech like that. So I was like super excited to work at a company that had this guy. And then sadly, Tim left us. And no, I'm not talking to a poltergeist right now. Tim just went to another company. And I was a little disappointed, but of course, where you went, they're a great partner in adjacent technology. So I turned that disappointment into the desire to kind of bring some of the content you brought to the company to Confluent in your stead. And that style has really inspired the way I've conducted myself as a PSE and now as technical champion getting to this role and this show. So I'm completely honored to go full circle and have you as my first guest. So I just wanted to do that and make you blush a little bit. I've succeeded in doing that. So
yeah. Anybody watching the video version maybe saw me blush, maybe saw my Christmas sweater. I assume this is going to launch after the holidays.
After the holidays, yeah.
As we are recording this, it is sort of mid-December.
That's right.
My Star Wars ugly Christmas sweater on, representing. Anyway.
Thank you, immensely for being the first guest. But we have a more important thing to talk about other than how much we like each other. We got to talk about data streaming, right? Mm-hmm. So let's jump right into it. What do you and your team do here at Confluent besides making mesmerizing content?
Well, it's our job to help developers, and by that we mean just all technical people, right? We're not super picky about operator or architect or the meaningful distinctions, but we just mean technical people. It's our mission to help developers adopt and succeed with the technologies of what we at Confluent call the data streaming platform. That includes things like Kafka, includes Flink, to an increasing degree as we move forward, Apache Iceberg. Technologies like this are things that only technical people use directly, and it's our job to help the world of the developers know that these solutions exist and how to get started with them, and kind of how to move through what I call the developer journey successfully with those things.
Right, it makes a lot of sense. I mean, what we provide here at Confluent, it's not simple stuff, right? It's like maybe if it's a very simple use case, but once you start to kind of get into enterprise scale and things like that, it's very difficult to know how to tie it all together, especially if you're trying to do it open source. So I really appreciate everything you and your team does. So for people that are viewing us that don't know, what does Confluent do?
Okay, Confluent makes, well, we'll start with the cloud, a fully managed version of that platform. Right. Now, that platform is also available in self-managed form if you just really like tarballs, or you can't run the cloud, or like whatever. There are a bunch of valid reasons, technical and business reasons, for that thing to exist. So there's the platform, and there's the cloud product that are that Kafka, Flink, soon to be Iceberg interface as we record this. All those things in a fully managed form. With, I'll just say, this purpose of our discussion today isn't to walk through the product, but a bunch of other goodies that you're going to need. And either you're going to do maybe the wrong thing and build those things, or you're going to get them from somewhere. And those all exist as an integrated part of we'll just say Confluent.
Yeah, we have all the data streaming flavors that you could want. So who are our customers? And maybe more importantly, who aren't our customers?
Well, our customers traditionally, I think, is they hail from all kinds of industries, right? Financial services always tends to be early adopters in data technologies. That was certainly the case here.
Right.
But there's people in manufacturing, there's people in retail, there's people in sort of digital native technology space. Anywhere you go, if you have, it sounds like everybody's our customer. That's not literally true, but if you have data and you're operating at this point above a mom and pop scale, right? Every business has data, and if you are a sole proprietor, flower shop, corner store kind of thing, well, you'll have Stripe, and you'll maybe use QuickBooks or something if you've made life choices that have led you there. You've got that kind of SaaS stuff. You're not going to use Confluent. You're not going to use Kafka. You don't build software. But if you're a company that does, you're big enough to write your own software, then there's a story there. You need to understand what's going on in your world with the data that characterizes your business. And that sort of analytical angle on data streaming is going to become important to you. It either is now or it will be. And you have applications, a set of operational concerns, right? Programs that help people run your business, or increasingly programs that sort of are your business in this emerging software-defined business kind of space. And increasingly, the application architectures that emerge there, just say microservices broadly, that's the thing. A data streaming platform has emerged as really the successful substrate on which to build that kind of operational estate.
That's a great way of putting it. I would say this pretty often, especially in my PSE role, is that not all use cases in tech are data streaming use cases, but all companies have data streaming use cases. And even to go to your example of the florist, right? That individual has a data streaming use case, right? They probably want to know, I have a new order, I want that instantaneously. They're not probably going to be the ones, like you said, working with Confluent directly, but they're going to be some consumer of some other technology that is likely built on data streaming.
For example, just to use one that is quite public about their use of data streaming. Suppose their website's on Wix and people can place orders, and they want up-to-date analytics of what their customers are doing on their little mom and pop Wix website, corner florist kind of thing with an online operation, not a giant business. Well, guess what, folks? There's Confluent in there. There's all kinds of data streaming going on in there.
Yeah, that's a good one. We're going to talk about data streaming engineers later, but does that mean all Wix users are data streaming engineers? It's interesting.
No, it doesn't. Most Wix
We'll
users
get them there.
are,
We'll get them there.
people making a website and putting plugins in it. And
But you have the power
Hustling.
of data streaming there.
That's the thing.
Right.
What we do here is infrastructure fundamentally.
Yeah.
And infrastructure. Think of plumbing in your home, and what we do is a lot like very smart plumbing. Most days, if you're not a plumber, you're not touching the plumbing, right? Like if you're touching the plumbing, that's a bad day.
That's true.
And so if you are that sort of mom and pop, small scale business where you don't write software, you don't want to think about it, you just want to get things done, you want to take care of your customers, there's plumbing back there, and there's plumbers who care. And that's, to a large extent, it's my job to keep the plumbers up to date on how to build things and what the right fittings are. And, there's this new press fit technology coming out. You should use this, all that kind of stuff.
That's a really great analogy, Tim. I appreciate that one.
It's funny when, what I do in developer relations always requires some explanation. I can't just say sales or engineering or something, it always requires a little bit of a story. And when I talk to people who work in the trades, it's much easier. And like everybody can understand the plumbing analogy,
yes.
But it's very visceral. Even if you're not a plumber, but you're some other kind of tradesperson, that just clicks right away. Like, oh yeah, there's these influencers that tell us about plumbing and all that kind of stuff.
Right.
It makes sense.
The data streaming plumbing influencer. I like that. Yeah. That's a direction I need to go now.
I follow some plumbing influencers on Instagram. They're pretty great accounts.
So, Tim, when were you first introduced to data streaming and event-driven architecture? And as a bonus, have you or any of your past teams ever had the pleasure of running open source Kafka yourself?
Take those two questions separately.
Sure.
I came to Confluent the first time in 2017. And I would like to say that I did that because I'm so good at picking horses and I'm such an astute technology analyst that I said, oh, this is going to be huge. This is heralding a paradigm shift in the way software and data architectures are built. And these are trends that'll last for a generation. I need to get some. Nope, wasn't that. It was still a good reason. I saw alignment with the executive team at this fairly young startup, between what they wanted out of a developer relations effort and what I wanted to do. And I'm like, okay, we could do things. And about 6 months later, I started to realize, oh, wait, no, this is huge. This is really huge. So it was then that the impact of, or the reality of the paradigm shift started to dawn on me. And I still am getting my mind wrapped around what it means. I think I have a pretty good understanding now, but this is a generational shift in the way data is dealt with, the way software is built. Kafka is, I like to call it a substrate, or you could say it's at the center of that story. And the pieces that are emerging on top of that, Flink, Iceberg, Schema Registry, these things, these are other components of that platform that are part of that story. And so I didn't see it right away. It kind of dawned on me over a little bit.
That's cool. I would have thought for sure, Tim, that you came in the door having run data streams for years. Like I really did. But I guess based on the timing of the size of the company, Kafka was pretty nascent at the time, so that makes sense.
Yeah.
Yeah. Well, you made a good bet, so good job.
And do we use open source Kafka? Yes, but it's not like we operate applications or production data pipelines. I mean, we use open source Kafka to build demos for things.
Sure.
To show people how they can build applications and data pipelines and so forth. So yeah, we have our hands on, and that's one of the noteworthy things about DevRel at Confluent, and in companies like us, strategically where DevRel fits into the picture, is we are people who actually spend our time and advocate for the open source foundations. Like that's an interesting thing to the business, because there's this community of developers globally who aren't yet asking, who's Confluent and how do I succeed with Confluent? They're saying, oh, I heard about, okay, I know Kafka. I heard about Flink. Looks like Flink is becoming a big deal. How do I know more about Flink? Another thing to learn. I need to keep on top of this. That's the question folks are asking. So we're there answering that question.
Yeah, it was kind of a leading question. So I had a startup before I came to work for even Amazon and before Confluent. Our stack was Kafka and Samza. And Samza is actually another project that Jay was a contributor to.
Right.
So I was like,
that's right.
I used to work inside of Jay Krepp's mind. It was kind of weird. But I used to deploy Zookeeper and Kafka using SaltStack, which I don't even think anyone even knows anymore. It's certainly, it was like a Puppet /
Okay.
Chef competitor. I don't know if
Okay.
anyone uses it, but
Maybe an also ran. I mean, I haven't heard of it. So
I did it, and it worked, but it was a pain. So I'm glad
100%.
neither of us has to do that anymore, because frankly, there's better ways to run data streaming now. Frankly,
yeah.
so now that we know you a bit better, Tim, and what you do, for our next segment, let's unravel the mysteries of how data streaming forms the backbone of modern event-driven architectures. So, what exactly is data streaming? And how does data streaming differ, or streaming data differ from different types of data? Right,
Yeah. There's a lot of ways to come at this. If you think of, what you know as a traditional database, we don't need to get fancy there or strip it down to first principles or anything. Just database. It's a place where you put data, and the data is going to sit there until you need it.
Right.
And this would also apply to a data lake, which I think is really not really a database, but it's a place where you put stuff and it sits there, and you might come back to it, you might not. We'll see. That tends to create kind of an intellectual pattern, or a way of looking at the world, that you think about the world as things.
Mm-hmm.
What are the things that are there? And if you're a technical person who has done this, if you've built an application in kind of the old client server or monolith style, you typically start with a database schema. That's like saying, what are the things and how are they related?
Right.
Now, that application processes events. Things happen, and that application deals with them, but those are secondary.
Mm-hmm.
And the data infrastructure underlying all that is a place where you put things, and they stay there, and they're things. So the streaming approach, the data streaming approach, is, also data is stored. Okay, data gets put somewhere and remembered, but kind of the shape of the thing, the basic semantics of how the infrastructure works and what things are like, there's things are happening. And so you don't put data there to go back to it sometime later, but data flows through the thing. And when a new event or piece of data or message or thing happens, the assumption is, well, you deal with that right away. And there's elements of both in both. Okay, you can do these things at small scale with conventional databases. You can do event-driven things, and you can use data streaming platforms to store data. It's even a good idea. But again, the shape of the thing is events are happening, and we will think about them, process them, make sense of them, act on them right away, not put them to come back to. What that means is the basic intellectual habit that you have in building a data streaming system isn't first, what are the things, but it's what is happening.
Mm-hmm.
So it's the event that comes to the forward from the thing. Now, again, in the old style, data at rest sorts of systems, things still happen, and you have to deal with that. And I assure you, in a data streaming system, the thingness of those events, that is their schema, what is it that they represent in the world, incredibly important. And for success at scale, tools to manage schema, validate schema, manage changes, understand lineage, publish, catalogs of descriptions of things that you can wrap your own automation around. Like, you will not succeed if you don't either buy or build something like that to build a system like this at scale. So the thing matters, but you start with the happening, and then you get to the thing.
I love that answer. So you mentioned databases, and you mentioned event-driven architecture. There's also these things like message queues that I'm sure our audience is very familiar with, if they especially been in the industry long enough. How does what Confluent does differ from, say, a message queue?
Yeah, from the old style. So there's the semantics of the, like the underlying data structure itself. Let's start there. So a queue is this thing that you put things in, and they come out in the order that you put them in. And when you take a thing out of it, it's gone, right? You've consumed it. So you act on it, you go, and maybe there's transactions and a bunch of fancy stuff. And so if you take something out and it doesn't work out and you fail, it'll stay, whatever, But when you successfully take something out of a queue, that is, poof, it's gone. Now you can't. So the underlying data structure in a data streaming platform is a log. which is a thing that kind of looks like a queue, and that things, basically come out in the order you put them in. But when you read them, they're still there. So this is this persistent substrate of data that, say there's some stream of events like orders coming in. I might be interested in writing a service that helps process payments or something on that. Somebody else might want to detect fraud. Somebody else might want to look at customer loyalty programs or something. And these are all different services, different programs that different people can write that are all consuming from that same stream of events. In a queue, you can't do that because once you read it, it's gone. And sometimes a queue is what you want. There's actually work going on in open source Kafka right now to give it sort of a queue mode so you can make it act like a queue because sometimes that's a good thing. But it's nobody ever built a company on that foundation. And in fact, the early 2000s, mid 2000s stuff that was going on with what we then called service-oriented architecture used queues like that and kind of centralized smart routing and processing of the data. And, there were, like everything, there are people who had success with it, but it didn't stick. It didn't leave a good feeling in everybody's mouth for reasons we don't have to get into, but that isn't, in another 30 years, people will still be talking about event-driven architecture. Maybe it'll be an old and busted idea by then, and there'll be younger people telling Grandpa what it's like,
how to migrate off of it, right?
Right. That could be in another generation or so, but they won't be building systems on SOA. That's just not
right.
They aren't now.
No, they're not. Exactly. It's like, how do we get off of that if we have it as quickly as possible? But just to kind of summarize that, you have, the ordering, you have the high throughput, but then you also have persistence like a database.
Yeah. Cool. As being a log that you write things to and you remember them for as long as you want.
Yeah, and that's why I think, I might be wrong about this. Correct me if I'm wrong, but that's why they called it Kafka, right? Because he liked to write.
I don't know. I know
log,
that
right?
that Jay Krebs, the guy who wrote it, is a fan of the author. I don't know if that was the reason, but I mean, Samza is the last name of the guy in Metamorphosis.
See, I didn't know that. See, it all comes back to Franz.
Yeah.
See,
so there's it's just certain people have affection for certain modernist authors, and the world has changed.
I'm gonna have to see if I can ultimately get Jay on the show. I want to ask him that question.
Yeah.
So, can you provide some practical examples of data streaming in action? Maybe a use case or two that most of the audience can relate to, or even affects them on a regular basis. And bonus, should that have been effect or effect?
Oh, that's that with an A.
Effect. Thank you. I appreciate that.
Them. Yeah.
I'll never get that right. So
if it's the word with an E and it has a direct object, then it's like causing it to be or something like that. If it's if it has a direct object, then it's probably just acting on me. So let's go with credit card fraud detection. That's probably the easiest. It's real. There are real fintech companies that actually do this with actual Kafka, and I imagine a number of them are Confluent customers. But yeah, so you've got this stream of purchases coming in this time of year. Again, Christmas sweater, certainly lots of purchases happening in my household. It's great. Love me some Christmas. But these purchases are coming through, and you need to know for each one, is it fraudulent? And you'd like to know right now. You'd like to be able to stop the transaction, because the credit card company's on the hook for that. The consumer's not. And so that event happens, and now there's a bunch of computation I have to do. There's things I need to know about the card number, the purchase history. There's all this kind of enrichment that has to happen. It's a fairly sophisticated thing that needs access to a lot of context and the real-time event. So there is this kind of whole platform. You don't just have a pipe of data. There's a lot of pieces of infrastructure that need to exist to make that happen. And now, your phone wiggles 5 seconds later and says, "Is this you? You just tried to buy an SD card in Paris. Does that sound right?" True story. I did that once, and it was really me. And my credit card company was like, No, I actually left all my SD cards at home. It's terrible. Here we are.
I really had to do that. Yeah, that's a dimension that you didn't initially mention, but location, right? Because if you had a successful card swipe on the East Coast of the United States and then a card swipe 5 minutes later in the middle of Europe, unless you are an X-Man, you can't physically do that. So something's up, and let's at least flag it to make sure the customer knows. That's a really good use case. This is a good one. I'm sure you talk about this all the time. What's the difference between batch processing and real-time streaming? And bonus, why do you think so many organizations struggle to migrate from batch to real-time processing?
So it's like the difference between a database and a data streaming platform. It'll sound kind of the same, but with batch processing, I kind of have my data in a pile. It's all there. I know where it starts. I know where it ends. Like I might know how many things are in it, how many records, or if it's a thing that breaks down into records, I could know how many there are because there's a first one and there's a last one, and I'm going to go crunch through them and do some kind of analysis. Maybe I'll just be computing an average or something, or maybe it'll be some big machine learning model, or I'm dumping them into a AI language model, whatever. But I've got the stuff there, and I can start working on it and go through each unit of work, and then I'll finish. And there won't be any more data. So it ends. With streaming, that means I've got access not to a pile of data, but basically a pipe where events are impinging on me. And so that work that I'm doing might be the same work. The computation over these records, wherever these events are, could be the very same thing, but I don't know when the last one is. There isn't really a notion of there being a last one until, the heat death of the universe, or I suppose the sun, or the business shuts down, or something like that. It's something kind of sad for there to be a last event in an event-driven pipeline or a data streaming pipeline. And why is it hard? Because it's new. So we've got literally the entire history of commercial computing from the 1950s until just recently has been centered around batch processing. Now, somebody's going to hear me say that, and they're going to say, well, actually, Tim, I built an event. Yes, of course. There have always been systems that respond to events. Some of them have specialized in that, but it's always been bespoke and unusual. It hasn't been the way everybody does it. And if you were a person who built that 20 years ago, well, you were a part of an unusual thing, and it was hard because you had to do it all yourself. And now it's a thing that the ordinary enterprise developer and architect is reckoning with because it's the new paradigm. And that ordinary enterprise developer and architect probably didn't start working a year ago. They probably got a few years on the clock, and those years are spent doing it the old batch way. Or in terms of application architecture, if not batch, what I call the client server or monolith way. Those we'll call them two sides of the same coin, data architecture and application architecture. And that's all everybody has spent their career doing. And it was hard at first when you were a new developer, and you had to get good at that. And there were other more experienced people helping you get good at it. And now everybody's saying, wait, no, it should be streaming and event driven and completely different way of getting things done. And we don't have that shared body of experience and comfort with the model because it's new. I wasn't a software developer writing code for the enterprise on PCs in the 80s. But I think that's the nearest historical equivalent of, I just spent 10 or 15 years of my career being a mainframe developer. Now I have to learn how PCs work and LANs and this junky database server thing, and why is my data over there, and UIs are all different. That would be a very different experience for that person with that mature skill set as a mainframe developer in 1986, pivoting to client server. Well, we're all doing that now with so much more software and a much bigger community of developers.
The body of work, that collective body of work, is really an interesting thing to kind of dive into, because you're right. If you just, like, when Kafka first hit GitHub, and if you were to look at it, there was no practical examples. If you said, I want to build around this, like, there were a handful, but does it scale? Don't know. Probably a million improvements that we call KIPs that needed to actually, eventually be built.
It didn't do replication then, right? Until like 3 years later, right?
Yeah. So you reminded me, like, you were talking about someone doing event-driven architecture like 20 years ago. It reminds me of, like, when I was a kid, I really liked comic books, but it wasn't popular. Like, I was like a nerd because
Me
of that.
too. Yeah.
But
No,
now, like
that was in
all
the
the cool
80s as a
kids
teen,
read comic books.
yeah,
We were just ahead of our
that
time.
was weaponized.
Yeah.
You don't let anybody know.
Right.
Right. Now, all of a sudden, oh, okay.
Yeah, we want to make data streaming engineers the cool kids. That's what we
Exactly.
advocate.
They already are.
That's kind of your job, but I'm sure you'll do it. I'm sure you'll do a great job.
They already are.
So can you, we talked around it, and I think we've hinted at it, but I'd like to ask you a direct question about it. Can you explain the concept of event-driven architecture and how it ties into streaming data?
Sure. And this again is a hot potato because different people are going to describe this differently. This is not the only possible account of it, but what I think of there is building an application in a number of small programs that interact. Okay, and this is microservices is another word for this. It's a fine word. If you don't like it, don't use it. But instead of one big giant program where the code is all in one code base and there's a database at the center of the world and a user interface on the outside of it, maybe some APIs and some message queues and whatever, but it's this one big thing. You break that up into pieces that are small enough, each one to fit into your head. Because that whole application, after a while, no one person really can comprehend it all. So you break it into pieces that are small enough for one developer to internalize, and those pieces then, of course, need to talk to each other because it's an integrated application. And what they exchange is events. So there is some sort of messaging substrate. We'll just call it topics in Confluent Cloud would be fine. Or Kafka topics or whatever we want to call them. And the application, the services that you're deploying to people throughout your company or exposing to consumers or whatever it is, are a bunch of little pieces, each one with a small unit of work to do that it consumes from a topic, does the work, and produces a result maybe to a new topic, maybe puts it into some kind of data store for reading, maybe keeps some keys in memory for exposure to an API that feeds a user interface, something like that. There's all kinds of things that service might do, but the application is now composed of a bunch of those little programs exchanging events with one another.
See, microservices and like Docker containers are just like another example of tech that came along with, the kind of the rise of event-driven architecture. And if you were trying to couple data streaming with like a monolith, doesn't really make a lot of sense, right? Because the monolith is kind of talking inside of itself. So that's another one of those things that kind of had to come along to make it tenable for most organizations to build EDA. It wasn't just Kafka, it wasn't just stream processing, it was things like containerization that make all of this, like 100%. Building these microservices a reality and I think that pulling your hair out.
Coincident rise of those two technologies, I think they reinforce one another, and they help. If you remember, say 2007, I think it was that EC2 went live.
Yes,
and we tell stories like, if a company does lots of business around the holidays, they could just scale up a bunch of servers and then spin them down with an API at the end of the holiday season. Like, that's so cool. Joseph, I wasn't building applications in 2007 that you could do that with. Okay. Right. That's nonsense. Nobody was.
Nothing scaled like that. There was no horizontal scaling. Are you crazy?
What? There's just that's not how monoliths scale. And now that sort of promissory note that we were living with for a long time. EC2 was tremendously valuable and useful. It wasn't like it was a sham or anything. It's just that story was really promissory in nature. And now that you're starting to have success with services-based architectures, microservices-based architectures, and I think the event-driven component, frankly, the rise of Kafka as a component of that, has made that possible. You would have needed containerization to come in there too, to really make that turn a dial and your application scales story be true.
Yeah, so it's kind of wild. Like even if you had an app that could horizontally scale in 2006, EC2 only had public networking. Like there was no VPC. Every single instance had a public IP and a key that you could log into it. It's just crazy to think that we're ever able to sell that, let alone turn it into the monster service that it is.
We over and over again, there's an idea, and we work on building that idea. It's very hard to build things.
Yeah.
And so we build a crappy version of it.
You get better and better over
And
time.
maybe it enjoys some success. Maybe it doesn't. I mean, if you look at the development of the telegraph, there were in the 30 or 40 years prior to Samuel Morse, a bunch of, in retrospect, kind of stupid ideas that you look at them and you're like, why are we trying to? Because it's really hard to come up with new ideas.
Yeah, you
It's
got to
best
like push the
anybody can do.
bubble of what is known a little bit, right? It's not, you can't push it too hard.
There's a great story. I need to remember the name, but the development of a mechanical clock that could keep time at sea for tracking longitude. Basically, this was before there was GPS. You needed clocks that kept time. And there was one guy there was this prize in Britain, Royal Society, 5,000 pound prize or something. A lot of money. And his first clock was this 2 foot by 2 foot thing, and it worked except this. And the next one was kind of the same size and it worked, but you couldn't rock it back and forth. And, that didn't really get it. The next one was like a little smaller. And then the one that won was like the size of a baseball. So you build a few kind of sucky versions of a thing before you really know how to solve the problem. And we see that over and over again with any kind of significant innovation. It's just that hard. And so, yeah, that was EC2 because it's hard to make things.
Yeah, I mean, absolutely. I mean, once innovation gets to that level of maturity, that's when things start to get really exciting. And that's kind of why I feel like where we are in the data streaming world. And I think this kind of leads into our next question really nicely. So, Tim, how do you think organizations will use data streaming in the future?
I think the end state and maturity there looks like sort of full adoption throughout the stack, or throughout the growing parts of the tech stack. And a business whose operational DNA is also oriented around real-time results, real-time insights, real-time actions. And so now what we see is people are building their first or second data streaming thing right now. And it's hard and it's new and folks are powering through it. And Confluent, I sound like a shill when I say this, but Confluent has for 10 years been at the technological and intellectual forefront of that problem. What we were building 10 years ago didn't look like what we're building now. Okay.
Absolutely. Very,
Very much simpler. Then we were talking about, hey, it's like faster than Hadoop, and now you're faster than, what'd you say? We've been providing that intellectual and technological leadership. Most people are taking advantage of that by building their first system, and you don't rip out all your old stuff and replace it with event-driven stuff, unless you'd like a new job because you got fired, right? That's and that didn't happen when relational databases were new. When they were client-server things were new, it was a net new system being built alongside the old one. Okay, and the old ones remain, but I think and eventually get chipped away and replaced. And modernizing mainframe applications there's still some mainframes that run and are very important, but you modernize those and you want to get off. So I think the future for data streaming looks like a comprehensive adoption of that architectural style for new applications, for most of the applications that matter, real-time data flows, real-time insights. There's no notion of ETL happening and you take the data from here and stick it over there and go think about it later. No. It's always, the insight is now and it's available to be consumed by anybody who wants to know what's going on. So a business that's built like that, and if your systems look like that, then operationally, and you can debate cart and horse, but at least you have the opportunity operationally to create a culture where you get to respond to the changing world right away, and what's going on.
So the future is
right away.
So the future is data streaming ubiquity.
Yeah.
I like
think
that.
so. And again, in 30 years, 30 years, we'll be there probably. And then there might be some new paradigm that you and I can't envision, that nobody can envision yet. That'll push that out. Maybe it'll take longer. I don't know. I mean, these things don't last forever, but this is, in my opinion, in my view, a generation long kind of work.
I love it. So Our next segment, Tim, is the playbook, where you dish out your winning strategies for getting old, tired, unmoving data in motion. So I've heard about data streaming engineers. Surely they must be in the playbook. Can you help us better understand who data streaming engineers are?
Yeah, data streaming engineers are these technical people. I'll call them developers. Now, your title might be architect. If you're a very hands-on coding architect, that's better, right? That's a good thing. But I'll just say developers who are working with data streaming technologies, and this is a big umbrella that now includes application developers and what we'll call data pipeline people, data engineers. Those start to look, they start to have more in common because there's common infrastructure that both are using. And that common infrastructure is kind of starting to dominate the work that gets done. And the line is blurring between the operational and analytical state. I think that's a consequence of what events and what data streaming do.
Agreed.
Is that they start to bring those two things together. There's still distinct areas of specialization within data streaming engineers, like saying software developer. I mean, come on, there's all kinds of software developers.
Sure.
Even data engineer, there's all kinds of different specialties within data engineering. But a data streaming engineer is this developer who works with data streaming technologies. Kafka, Flink, potentially Iceberg is this unifying thing between the operational and analytical state. Whatever other pieces emerge in the future, you'd mentioned indirectly real-time analytics that I've been working in. There's some part of your stack that that's going to provide that sort of insight. So, data streaming engineer is a person who works with these technologies, whether you're on the application or pipeline side, it's you.
I like that you left room for future technologies, because I think, as we get closer and closer to that data streaming ubiquity, there's going to be new tools or technologies that emerge that are going to be part of that toolkit that we can't predict today.
Landing on a habitable planet and, you don't have satellites to take pictures of it for some reason. This is my story, work with it. And, you're just exploring the landscape and you don't know what you're going to find. That's where we are. Now, we know some things. We know some things very well about that landscape, but there is new territory and new terrain to uncover, and there are new infrastructure components in this new stack that I can't tell you what they are yet, but I bet if you ask me in 2 years, I'll be able to tell you.
Yeah, absolutely. Yes, somebody's committing something to GitHub right now. It's going to change all of our lives. I guarantee.
Or it's an existing thing with a user base and a business, and we just don't know
that catches
that it's
fire.
really going to emerge.
Yeah.
We're figuring those things out, like
Absolutely.
we did with Flink.
So what are the top 3 tools a data streaming engineer should have in their toolbox? Or conversely, tools that they should avoid, like, batch processing?
Okay. I'm thinking actual infrastructure tools. And so we're going to go with Kafka. You got to know the basics. Going to go with Flink. It's definitely time to know the basics. That's not exclusive. There are plenty of folks who are having a lot of success with Kafka Streams. That's one that might well be in your toolbox. You might be very excited about that. And I see, as I look to the next year, I've mentioned Iceberg a few times, I think it's going to play a more important role here as we deal with this bifurcation between operational and analytical data. It's a 50-year-old problem. We've come up with a number of ways to solve it. None of them has really quite seemed right. And they've worked, but they've had a lot of trade-offs and friction and so forth. And I think we're in a place where Iceberg could be a part of unifying that divide in a potentially new way. So definitely Kafka, definitely Flink. If you're looking for new things to learn, I think it should be Iceberg. And if you're a Java developer, knowing some Kafka streams, not going to kill you.
Excellent. Can you share a specific tactic that has significantly improved a customer's data streaming journey?
This would be kind of more architectural and interfacing with business stakeholders.
Yeah, I just wasn't sure if anything ever bubbled up to you that
technical. And it's almost a cliche, but we always need to be reminded of it. You need to find the pain. You need to find a thing that hurts. Find a thing that visibly gets bad results for the business. So you're looking to become a data streaming engineer. You're looking to maybe you're in your career past where you're working on engineering things, but you still have sway over chunks of data architecture, and you're aware, okay, this is new, this is a path to, major results and success and things like that to deploy a system like this. Well, hopefully you already know, but if you don't, you got to look for what hurts. There might be systems that are still running mainframe code that was running in 1982 that never got migrated onto a PC and then onto a web server and then onto a Kafka consumer or whatever, because it's fine. It doesn't hurt. It's working great. You need to find the things that hurt. And those things probably hurt because they don't change fast enough and they don't tell you about the changing world fast enough. And those make them good candidates for broadly the set of technologies that we call data streaming.
Yeah, that's a great tactic. I mean, especially I've worked for many enterprises of every size, and to get anything to change is not easy, right? So if you're like an aspiring engineer and you're like, hey, I found this, how can I make the business actually steer the giant ship, a few degrees to the right? Pain's a good starting place in asserting that you can make it go away.
And in defense of that corporate conservatism, it should be hard to change things. You shouldn't just...
That's true.
Because people like you and me, we'll get excited about the new thing because it's new. And, like, oh, let's do this. And that's great. That's fun. I have hobbies for that. The company has customers to take care of and shareholders to provide value for. And so the default is no, don't change it unless it hurts.
Yeah. Yeah, absolutely. I mean... That's how, like you said, that's how you get fired, changing things without actually showing business value and blowing things up. So this is another one that's a bit architectural, but I think I'd still like you to take a crack at it. In your experience, how do our customers evaluate and select new tools for their data stack? Specifically with moving towards event-driven architecture and data streaming, how do they balance factors like scalability, cost, and integration with existing systems?
Yeah. Everybody's got kind of a slightly different bake-off spreadsheet of what those things are, and that's contextual enough that you sort of have to do that. Like scalability is good. Everybody wants scalability. That means different things for different people. That upper bound, and you'll know what that upper bound is. You'll know. Is this going to be a real challenge for a vendor? And you'll know, is this going to be a real challenge for a vendor to scale to your level because you're just so big or what, right? So scalability is going to matter. Integration with other systems. You're going to know what those systems are for now, at least for your system that you're building. You know what you need to connect to. And you can go look, okay, these guys say they've got hundreds of connectors. They've actually got like 5. These guys, there's like 80 connectors that I could run in the cloud here. And I haven't even heard of some of these things, and all my stuff is there, So I think that's the easy stuff. Okay. You know what those things are. You're going to look for them, do the work, qualify the vendor. I like Confluent's chances when it comes to that. The advice I give broadly when it comes to technology selection is, one of the first things, and maybe this makes sense given that it's me, but you got to look at the community around these things. At a certain point, a vendor gets to a size where you can have a reasonable certainty that vendor is going to be around, in some form, as much as you are.
Yeah.
You also want to know, is there a collection of people globally using similar technology or the same technology? Does that thing have truly a community around it? And with Confluent, Confluent started by the people who originally created Kafka. That's true, but there's this global community of people making, developing Kafka, developing different compatible versions of Kafka, doing stream processing on Kafka with things like Flink and Kafka streams. There's all these people in this global community. So I tend to try to point people to where the action is, and that action is always going to be more than one vendor. Now, that vendor has to give you what you want, and they have to be solid, and they have to be big enough that you think you can bet, if not the business, at least this application on them. And so that vendor really matters, but there are questions beyond that vendor, and there ought to be, when it comes to something foundational like data infrastructure, you really got to make sure, is there a global community around this? And again, that's, I've not seen many more thriving, vibrant communities than the one underneath data streaming.
Yeah, couldn't agree more. So for our next segment, we've heard Tim's wins, strategies, and general musings on how great data streaming is. But as nice as Tim appears to be, don't just take his or even my own word for it. So we're going to watch a quick clip. And Tim, I'd love to get your reaction. And just a reminder for our audience, this is episode one. Episode 1, episode 2, and episode 3 are what are part of our foundational series for Life is But a Stream, where we talk about and we establish what data streaming, stream processing, data integration, and governance is. So in future episodes, we're going to have our customers who have actually built great things with it. But I want to make sure that you kind of understand all of the pieces to what we call the data streaming platform before we get into those. So for today, in the next 2 episodes, we are going to feature at least a video from one of our customers. So for our audience that's just listening to us, I'll kind of set the clip up. So in this clip, you'll be hearing from Virtua, a European company that provides smart EV charging services for over 1,000 companies across many industries. And here's how data streaming helped their big data problem.
We are a global company. We work on the electric vehicle charging. Virta's goal is to create a more sustainable future by making electric vehicle charging profitable for companies and also accessible for people.
We grew quickly and we were handling a lot of data from thousands of electric chargers. The amount of data was unmanageable with millions of messages per hour. We required a core that can handle this amount of data. That's what led us to data streaming using Confluent.
Each service in our platform provides different types of data. Data streaming helps different services consume the data and bring it all together so it's not siloed. We are now thinking more in terms of data products, which means creating streams of governed real-time data that's then in turn usable for different purposes.
Working with Confluent has made our life a lot easier. We can reliably process about 45 million messages per hour, and billing is based on our usage and throughput, which is more cost-effective than self-hosting Kafka. Anyone working with Kafka knows that managing and maintaining a Kafka cluster is a very difficult task. Confluent Managed Kafka grows with your requirements. So you don't need to think about like, if my cluster now can handle this amount of data, it automatically expands with your usage.
The key thing I see from Virta there is that managing data infrastructure is probably not your job. So their job is to serve their actual customers, right? And help people have charged EVs and, you know, all the problems that I'm sure are manifold around all of that. And if you're providing a feature in your service or application or anything in that stack to help somebody charge their car better or cheaper, you're providing differentiated value. You're making your business more valuable to that customer. And that's a good thing. If you're making the plumbing work better, you could have a competitor that is also in the job of making EV charging better, and you're no different. You don't make yourself different from that competitor by virtue of making your data infrastructure better or operating it or just keeping it up and running. That's not the business you're in. It's very tempting, right? Might be interesting, might be fun. Often not actually to manage data infrastructure, but it's the only way that's your job is if you are a data infrastructure provider, like we are. Everybody else, it's not. Caring for your customers is. Don't build infrastructure components, and don't operate infrastructure unless, you know, there's somebody like a government telling you have to for some reason about data sovereignty or something in your business. You know, it's not what your job is.
Right. If somebody else can run some other critical piece of infrastructure, and going back to earlier in your conversation, and you trust that vendor, let them do that. So you could do the best at EV charging or whatever it is, the thing that you do. Yeah, I like that. Now on to maybe our most important segment. So we've discussed what data streaming is. We talked about strategies, who a data streaming engineer is, and we've heard from one of our customers on how data streaming is transforming their organization. Now it's time for the real hard-hitting stuff. Our data streaming meme of the week. I thought this was perfect considering you represent DevRel. So
There you go. Exactly. Yeah. And we love memes. I mean, people love memes. If you don't love memes, I'm not, I don't want to say you're not a person.
You're in the
That's
wrong
not true,
era.
'cause I don't
You're in the wrong era.
understand. Again, from an operational perspective, okay, because you are going to have to, your developers are going to have to understand how to work with Kafka, even if you use Confluent, because those are the APIs that are exposed for that layer. You'll have to know how Flink SQL works, because that's the API for the stream processing. These are fine. But do you want to know how to turn all the dials to make the thing work in production? Again, the folks who started early before there were no options, that's where you get these really seasoned operational teams who are like so good at it, and they don't have a reason to pivot because they're just the best in the world and everything. And that's cool. I like to hang out with those people.
They're rare,
but
though.
That's not most companies. And so you don't want to have to learn all that stuff to be able to operate in production you'd have to. That's just the misallocation of resources.
I like that. Like Confluent helps you just focus on the pieces you need to build that differentiated business logic, whatever you need to do to be, to charge EVs better, faster and better, right?
Right.
Before we let you go, Tim, we're going to do a lightning round. Bite-sized questions, that's BYTE, with bite-sized answers. Like hot
Okay, I'll go
takes,
fast.
but schema-backed and serialized. Are you ready?
Of course. Do
Okay.
it.
What's something you hate about information technology?
It's a loaded question. There's a lot. Just say computers.
Just computers.
Just computers.
I love it. Okay, we're gonna move to tablets only in 2025. What's the last piece of media you streamed?
It was a YouTube tutorial on FreeCAD 1.0. I do some 3D printing, and so I'm
Very appropriate.
pivoting from Fusion 360. So now everybody knows.
Perfect. What's a hobby that you enjoy that helps you think differently about working with data across a large enterprise?
It's an easy one. Hardware hacking, firmware development, and it's all not all about moving data. Sometimes about computation on data, decision making on data, but there's always data moving around, and whether that's Kafka topics, data in a topic moving over a VPC, the consumer on the other end, or a couple of wires with the serial peripheral interface operating at 5 megahertz, and how long can the wires get before you have to put you're just thinking about data moving all the time, and I love it.
Right. When data moves around you, all the data is moving. I like that. Can you name a book or resource that has influenced your approach to building event-driven architecture or implementing data streaming?
Not so much event-driven architecture, but in general, I want to say the book that is emerging as the most influential technical book I've read is called Implementation Patterns by Kent Beck. It's not even his best-known book. I think it's highly underrated or underread, as far as I know. But it's really a book. The purpose, the underlying message of the book is that you have to create systems that are understandable for other people. He's talking about code. You have to write code so that it can be read by people. I mean, making code that the compiler can read and it can do the right thing, that's comparatively easy. Making it so that other people can understand it, that's hard. So building systems in a way that, as it were, loves your neighbor, has a huge impact on me.
I love it. What's your advice for a first-time chief data officer or someone with the equivalent impressive title?
Same thing as before. Find the pain. What is your boss mad about, or scared about, or anxious about that is in your domain? Find some way that you can, within 3 months, make that not hurt as much.
I love that. Okay, so any final thoughts or anything to plug, Tim?
Yeah, the technical folks on your team, or you, if you're a technical person, should go to developer.confluent.io. That's Confluent Developer, the home of Confluent developer relations on the web. Lots of great video courses, executable tutorials, all kinds of helpful resources there. Links to meetups, everything you might want to know to move forward as a data streaming engineer. Coming soon, next year, be a certification program there. A certified data streaming engineer. You want that.
Well, thank you so much, Tim. I really can tell you, kind of the way I set up, like from my personal history here, it really is an honor to have you as a guest, but especially for this inaugural episode. And for the audience, that's right, you, particularly you, please stick around because after this, I'm going to give you my top 3 takeaways in 2 minutes. That was just a fantastic conversation with Tim. I mean, so many of his answers and insights really did surprise me. He really was the perfect guest to have for the first episode. So one of the first takeaways that I think is really important for anyone who's trying to really dive into this data streaming journey, maybe for the first time, maybe you're at a company where things have been running the same way for a long, long time. That idea of finding the pain, I think that is the perfect way to affect callback your ability to make the business case to actually go and take on that effort of building something net new or migrating off of something that's been running for a while. So find what everyone hates and then figure out a way to utilize data streaming to fix that. Another big surprise for me. Wow, I could not believe that Tim wasn't like huge into data streaming before coming to Confluent. Again, considering the timing, it does make sense, but he has always spoke so passionately about the subject. I just assumed that he was like an industry expert before he got here. And it turns out that he's just really good at talking about technology. And he came to work for an awesome company. And now he gets to talk about data streaming. And that's to all of our benefit. And then what I really liked about that use case that Tim talked about with financial services and fraud detections, I think it really is just, it's a universal use case, right? I think anyone that's ever used a bank, especially if you've been around long enough, you'll realize that things have gotten a lot faster in banking. It used to take weeks before you would get like a loan application approved or denied. Now it's happening in the same day or the next day. That is also powered by data streaming. The fact that these things aren't done in multiple batches, which is the reason it took so long. If you look at those improvements, but also, the specific use case that Tim talked about with fraud analysis, it's a really great way to explain data streaming, right? You have all these transactions, they're constantly moving at thousands or millions of transactions per second. And we need to find a way to identify outliers, anomalies, and data streaming and stream processing, which we'll be talking about heavily in episode 2. So please do come back for the next episode, are really the underpinnings of being able to do that. So it's a really exciting use case as like to get your mind churning about what data streaming is. That's it for this episode of Life is But a Stream. Thanks again to Tim for joining us. And thanks to you for tuning in. And as always, we're brought to you by Confluent. If you'd like to connect, find me on LinkedIn, tell a friend or coworker about us, and subscribe to the show so you never miss an episode. We'll see you next time.